Hi guys, it's our next part of Scilab. What did we do last time? We downloaded Scilab and started going through this document, which is available on Canvas. We covered sections 1 through 5, dealing with matrices, Scilab basics like operators and the command line and things like that. You guys had a homework assignment. I made a video where I did a few homework problems and I posted that in the announcements for the class. So check that out if you haven't. Okay, so today our sort of goal is to get through plotting graphs and learning a little bit about the programming environment. And then we will be done with our introduction and we can start doing some other fun stuff with Scilab and computational operations with Scilab for fun. Yay, fun! Scientific computation unit. Okay, so I'm just gonna scroll down to where we were. But I guess before that, before I really get into that, let's open up Scilab. So double click on my little icon here, and what I want to do, well, I'm gonna go over graphing, because before I get to the programming environment, because it's more like commands that you can type into this into the command line here. More commands that are useful, like graphing data is often good. So in the last video I made, which was the homework help, it said, hey, there's a cool function here for importing CSV files called CSV read, and I did the example of how to do that for the NASA data. So today I have a different data set. It's a little simpler to use. This was a pendulum experiment that we did last year. So you can imagine a pendulum. The variable that we switched up was the length of the pendulum. And so this was our dependent variable, 5 centimeter pendulum. We incremented by 1 centimeter all the way up to 13 centimeters. That's how long the pendulum was. And then we would swing it. It doesn't say which angle we use, so we would start the same place every time. And it would swing, and we would time how many seconds it would take to complete one oscillation or one back and forth movement. So for a 5 centimeter pendulum, it took 12 seconds. And I'll tell you, this is the time for 10, I believe. I don't know. 5 centimeters, this seems sketch. That's a really tiny pendulum, right? And I don't know why it's taken so long to do this. So these numbers look a little iffy, but it doesn't actually matter. So again, this was not data that I remember taking this, but I think this is probably the time for 10 oscillations. Anyway, looks like we did 2 trials of this, and we did an average here in Excel. So I want to graph this. Right? I want to graph my dependent variable versus my average. And I want to also maybe graph trial 1 versus the dependent variable in trial 2 and see if there's that much difference. So these are graphs that I'm interested in doing. Okay, so how do I import an Excel spreadsheet? Well, I have to save my spreadsheet as a CSV file. So I'll show you how to do that in Excel. You go to File, Save, Save a copy. And then instead of Excel workbook, you want to scroll down to comma delimited CSV. I am just going to call it pendulum data just so it's a little bit easier to read. Sure, we'll save it at the desktop. Why not? Don't show this again, man. What's wrong with you? Okay, so this is the CSV file and it's on the desktop. So I'm now going to change my working Scilab directory to the desktop. Sure, let's open the desktop up. So there it is. There's pendulum data on the desktop. And again, you can use a Scilab folder where everything lives. That's probably the best thing to do if you make a separate folder. And again, how am I going to read this file? CSV read is the function name. It's right over here in this little box that said, hey, we got rid of load. We got a better function. And so we need to type in the file name. And the file name is pendulum data.csv. You have to put, if I type this in, it's going to read it from whatever directory I'm in. So you have to put it in the same, you have to make this match that. So should work. High five. Ooh, we got some numbers and a bunch of other gobbly-goop. So you know what I forgot to do? So the gobbly-goop is these words right here. This is actually really easy to delete, so I'm just going to delete it in Scilab. But usually what I do is I just delete all the stuff in Excel and then save it as a CSV file, so it's just numbers. But let's practice our, let's save this as a, let's call it data. Let's save it as an array. So now I have a data array. It's a 14 by 4, and I want to get rid of the first 1, 2, 3, 4, 5 columns. So the way I would do that is, oops, the way I would do that is set it equal to nothing, and I want the first five rows, I'm sorry. So I believe that it's row like that. So first row should disappear, which it did. I can actually keep doing that because it's just deleting the new first row. So I did that command 5 times, and I have data. It's just my, yeah. So there's a couple different ways to do this. I like separating my X and my Y variables as different columns, but you can leave it all as data if you want, as one matrix, but I think easier to do this. So my X, I want to plot something on the X-axis and something on the Y-axis. And you know what's crazy is I will actually draw on a piece of paper sometimes what I want it to look like. You know what I mean? Like, I don't have a piece of paper, but I do have Smart Notebook, which is on my Smartboard app. So I'm going to just show you what I would like a graph of. Look how slow it takes to load. Maybe that won't work. But, oh, yeah, there it goes. Gosh, welcome to Smart Notebook. You thought you would never have to see horrible Enrique typing on the smartboard ever again. Were you wrong? Where's the marker? Okay, so there's the marker. So I want a Y and an X. And what do I want on the X-axis? I want, let's look at my data again really quick. Which one should I put on my X? That one or that one? Dependent variable, right? So this should be length. This is the thing I controlled, and I will have... Ooh, this is bad. But anyway, I'm going to have some of those. And over here is going to be time. So this is my time, is my Y-axis. And this length of the pendulum is the X-axis. So let's go back to my Scilab. Just doing that step, it's like I'm planning. It makes it a lot easier in my brain to think about it. This is my X, and that's my Y. So X is going to be taken from the first column of data. So what did this command just do? Remember, when you're doing arrays, the first thing is row and the second one is column. So it's saying first column, and the colon operator says everything in that first column, right? Guess what my Y variable is going to be? It's going to be everything in the fourth column. So there you go. Now I can graph it, because I've got my X data and my Y data. The command for graphing in Scilab is plot. If you ever need help with a new function, help plot. look, a two-dimensional plot x versus y. And then you can create other things like line specifiers and different other things, which I will just, it's best to, again, just go down and look at examples. So like plot x and y, you're going to get something like that. If I want to draw 3 of them with different colors, how do I do that? So that shows you have to do brackets. What if I want to plot weird things and circles and blue? These are cool. These are actually really cool. How do I do that? So again, you can look at the examples. Ooh, that one's really cool. So look at the examples here, and they show you how to make these really cool graphs. But I'll just start with an easy one. We'll plot x versus y and see what it looks like. So this command is going to plot these 9 versus these 9. Boom, there it is. That is what the graph looks like. Kind of not very fancy. The other ones looked fancier. So let me just explain something really quick, and that is, if I wanted to doctor up my graph without typing anything into the command line, I can just come on here and tools. You can do it on here. Edit. So like axis properties. I think you can put on your titles in here. So like my let's go to X actually. This is like, so this you can change like the data is right now it's from 5 to 13, so I go from 0 to 13. Right? And that'll kind of normalize the graph a little bit. It starts at the origin. Right? Start this at the origin as well. So, you can kind of mess with that. Then there's like, I think this is the overall title. Period. See what happens. I'm not actually sure where the label is going on that title. Anyway, so you can, let's quit this for a minute. Edit figure properties. So I think this is, no, this is colors and things. I'm trying to find, you can go into here and add titles and stuff. Anyway, I'm not going to get too much into this. Little menu to make it a little bit better. But like, let's go back to Scilab. Finish what I was doing. Here's the console. Oof, look at all this stuff it's been doing on the command line. I'm like, what am I doing here? All right, let me bring up the graphics window and okay, let me replot it like I'm starting over. Well, X, Y, there it is. So what I want to do, instead of what it's doing right now is connecting a line between all the dots. And I don't want to do that. What I want to do is have actual X's instead of dots. So the way I do that is I specify the marker type. And I do it with this little symbol, this little apostrophe, and then I could put in, let's say, circles. So the O is the command for circle. So if I do that, oops, what's wrong here? Like that, is that what you have to do? There it is, you have to end quote.